AP Physics Day 12, page 313, number 64. Here's a somewhat unrealistic conservation of momentum problem. You have a satellite elastically colliding with an asteroid. Well, it will not be an elastic collision in real life, but here, just for practice, we're going to practice an elastic collision. One of the keys there, make sure you're looking at that when you read these momentum problems. When you have an elastic collision, kinetic energy is conserved. Don't assume an elastic collision unless they tell you. But we have extra information. There's kinetic energy conserved in addition to momentum. Momentum is always conserved in any collision, whether it's elastic or inelastic. So I have this spelled out like we normally would do a momentum problem, conservation of momentum. We have before the collision, just immediately before the impact, and then after the collision, immediately after the impact. I've shown you the two objects in both cases, and then I've labeled the velocities. The first v sub 1 is 10 meters per second. That's the velocity of the space, or the little satellite going to the right. The asteroid has no velocity. I'm calling it v sub 2. V sub 3 is the little satellite bouncing more than likely backwards. We'll deal with that directional aspect in a little bit here. I'm calling that v sub 3. And then v sub 4 is the velocity of the asteroid after the collision. So we have to look at all the momentums here. We'll have p sub 1, which we can do in our head. It's the mass times the velocity. It's 10 times 100, which is 1,000. I'm going to leave the units off for now. That's to the right. And then p sub 2 is 0. P sub 3, let's assume we don't know the direction right now. It will be m, the mass, times the velocity, and we call that v sub 3. And then p sub 4, back, I do know it's to the right, is 300 v sub 4. Alright, so we do know that p sub 1 plus p sub 2 equals p sub 3 plus p sub 4, conservation of momentum. I can write that down symbolically. P sub 1 plus P sub 2, conservation of momentum. By the way, on the AP test, it'd be good for you to write down at the top of the page when you do this problem, conservation of momentum and conservation of kinetic energy. You'll probably get points for just writing those statements down, because that's what this is. We also know, I'm not really giving myself a whole lot of room, that KE1 plus KE2 equals KE3 plus KE4. Sorry, this is coming out sloppy here. Alright, so I'm going to give myself a little bit of space here. So bottom line is we have, if we look at this left-hand side here, we have 1,000 equals 100 V3, V sub 3, plus 300 V sub 4. And then the kinetic energies, which I didn't spell out yet, which would be 1/2, hope I have space, 1/2 mass 100 times 10 squared. So I have 1/2 100 times 10 squared plus 0 for the non-moving asteroid before the collision equals 1/2 100 times v sub 3 squared plus 1/2 of 300 times v sub 4 squared. It's v sub 4 squared there. I'm sneaking that in. Alright, let's do some simplifying here. On the left-hand side, and I'm going to move the variables around too. I'm going to divide everything by 100. So bottom line is we're going to get v sub 3 plus 3v sub 4 equals 10. If you divide everything by 100 and flip the equation around by the reflexive property, or I should say symmetric property. Okay, over here on the right, multiplying all the numbers, 10 squared is 100 times 100 is 10,000, divided by 2 is 5,000, equals 50 v sub 3 squared plus 150 v sub 4 squared. Alright, can I divide everything by 50 and flop it around here? If I do that, I end up with v sub 3 squared plus 3 v sub 4 squared equals 100? I believe so. Alright, so what I have here is a system of equations, and it's going to take a little bit of algebra to solve this. These two equations are what I have. And let me help you along with this a little bit. I think I'm going to take the one on the left here, solve it for v sub 3, and plug it in to the equation on the right. In other words, I'm going to have v sub 3 equals 10 minus 3 v sub 4. I'm going to plug that, I'll circle that, in for v sub 3, and I'm going to have to square a binomial. We haven't done this in a while. I'm going to go to the top of the page here. Alright, so I'm anticipating a lot of space here. I started a new page. This is going to be kind of fun. We haven't done a good algebra problem in a while. I've substituted in for v sub 3 the expression 10 minus 3 v sub 4, and I have to square that binomial. So let's go back. We haven't done this in a while. This is fun. 10 squared is 100. Basically doing the FOIL, first, outer, inner, last, or when you're just squaring a simple binomial, you square the first one, you multiply the two terms, and double it. 3 times 10 is 30, plus times 2 is 60, so it's going to be minus 60 v sub 4. And then you square the last one, so it'll be negative 3 squared is 9, plus 9 v sub 4 squared, plus 3 v sub 4 squared equals 100. And now you see something, well, for me, I see something that warms my little algebraic heart, and that is the 100s on both sides. Those are going to cancel. Well, that's so much fun to do. You're going to be subtracting those from both sides. Those will cancel out. I'm going to rearrange things, simplify to make it look nice and pretty. Add like terms. 9 plus 3 is 12 v sub 4 squared minus 60 v sub 4 equals 0. One thing I'd also like to do is divide, both of those are divisible by 12, the two terms. Divide by 12, you get v sub 4 squared minus 5 v sub 4 equals 0. Wow, that looks really nice. Now I can factor out the v sub 4. That's always fun, factoring. V sub 4 times the quantity v sub 4, because to factor out a v sub 4 from v sub 4 squared is v sub 4, minus 5 equals 0. So if you have two numbers that multiply to give you 0, either the first number, the v sub 4, either v sub 4 equals 0, so it's either v sub 4 equals 0, that would solve that, or v sub 4 equals 5. The second factor, the quantity v sub 4 minus 5, has to equal 0. So those are the two solutions, v sub 4 equals 0 or v sub 4 equals 5. Now we have to put this in context with the problem going back to the previous page. Alright, so obviously this is easier if we have everything on one page, but if I'm looking at this page now, from what I just found out, either v sub 4 equals 0, which it doesn't, because when it's struck by the satellite, it is going to move, so that's going to be an extraneous solution. V sub 4 is not 0. But let's check out v sub 4 being 5. So if I look at the very bottom of the page right now, of this page, right down here, I want to solve for v sub 3. Well, v sub 3 is 10 minus 3 times v sub 4. You can do that in your head, but I'll go back up to the top of the page just so I have space to do this. I know, and we can do it in our head. We know that v sub 3 equals 10 minus 3 times our v sub 4, which is 5. So v sub 3 turns out to be negative 5 meters per second. And then v sub 4 was our 5 meters per second. And if you start to look at this and do enough of these problems, you'll see a pattern, but let me just circle this. In other words, after the collision, the satellite bounces backwards at 5 meters per second, and the asteroid moves forward at 5 meters per second. They don't always come out as 5s, and in this case they did, but what you'll notice in the problem asked is, what is their relative speeds before and after the collision? Well, the relative speed before the collision to each other was 10 meters per second. And what is the relative speed afterwards? Well, it's 10 meters per second. They're separating. Before the collision, they were coming together at a rate of 10 meters per second. Now they're separating at a rate of 10 meters per second.